Okay, ladies and gentlemen, this is the bonding practice exam. This is a practice exam for the second IA coming up in 2 days. Oh no, scary. Chemists die. Yes, chemists die. All right, let's start with number 1. Given the balanced equation representing a reaction, here we have 2 H2Os plus energy yielding 2 H2s plus O2. That's a mouthful. But the question is asking which statement describes the changes in energy and bonding for the reactant. So you're focusing on the location of energy right here. So energy is on this left side here. So before this reaction is happening, this energy is being absorbed. So when you see energy on the left side, that means energy is being absorbed. All right? And when energy is absorbed, just think about it. Do that whole hand motion where you're getting angry and you're absorbing energy and you're breaking something. So you break bonds, you absorb energy. So actually you absorb energy to break bonds. Okay. Whereas on the other hand, you're doing that whole clapping motion and you let your fingers flutter away to show the release of energy when you form a bond. So think about getting angry, you're absorbing energy, and you're breaking a bond. So here, we're breaking that bond of H2O to make H2 and O2. So here, energy is absorbed as bonds are broken. Choice 2. All right, number 2. What occurs when hydrogen reacts with fluorine to form hydrogen fluoride? So we need to look at these elements, H and F. What are they? This one's a nonmetal. So is fluorine. They're both nonmetals. Now, both of these together, they make a covalent compound, covalent bonds. And when you have a covalent compound with covalent bonds, electrons are shared, whether equally or unequally. So electrons are shared and the bonding is covalent. Next, which element reacts with oxygen to form ionic bonds? On the other hand, we have ionic. So ionic is based on metal and a nonmetal. Here we have oxygen. Oxygen is a nonmetal. So we're looking for any of these elements to be a metal. So chlorine is not, calcium is, while nitrogen and hydrogen are not. So that's choice 2. Number 4, which sample of matter has a crystal structure? So crystal meaning we should be thinking about solids or ionic substances, or better yet, some network solids too, and metals. All right, so H2O, if you looked at L there, that's a liquid. Hg is a metal, but look at that right there. That's L for liquid. Nope. CH4, that's a gas. And then NaCl, it's both ionic and look right there, it's S for solid. There we go. Number 5. A sample of a substance has 3 characteristics. Or, no, I can't English right now. Has these characteristics. Melting point of 984 Kelvin, that's really high. Hard, brittle solid at room temperature. Poor conductor of heat and electricity as a solid. Good conductor of electricity as a liquid in an aqueous solution. What kind of grammar is that? As a liquid in an aqueous solution. Okay. All right, so let's look at these. Let's look at each of these. This one right here, this is a pretty high number, so it's a high melting point. This one's hard, brittle, solid at room temperature. Okay, keyword there, solid, and it's hard. Poor conductor of heat and electricity as a solid, but it's good as liquid in an aqueous solution. So let's think about these two. What follows both of them? That's ionic. So ionic compounds follow this. So think about salt. It's not really that conductive when it's a solid, if you think back to the lab, but when you mixed it in with water, it dissolved into its ions, and because of these ions, it's got these flow of charges and everything. So with these flow of charges, you're having electricity. So that's why it's better as a conductive electricity when it's in liquid or in aqueous solution. Okay, so that word right there is supposed to mean or instead of on. Whoever did this made a mistake. Choice 3, ionic compound. Number 6. Which compound has the strongest hydrogen bonding between its molecules? So hydrogen bonding. Hydrogen likes to have fun. How frisky of it. Okay. Hydrogen bonding. So that means we're looking for compounds with either F, O, or N. Well, let's leave choice 1 right there. HI, nope. HCl, nope. HBr, nope. So it's just HF. Because it contains fluorine, which is part of the whole phrase, FON. Number 7. A molecular compound is formed when a chemical reaction occurs between atoms of what? So keyword here, molecular. That's another way of saying covalent. All right? So for covalent, you need to think about at least more than one nonmetal together. Nonmetal plus nonmetal. Looking at choice 1, chlorine and sodium. This here is a metal, so it can't be that. Chlorine and yttrium. Yttrium is also a metal that's in the transition metal side, so that's not choice 2. We have oxygen and hydrogen, both nonmetals, so let's keep that on hold. And then oxygen, magnesium. Magnesium's a metal, so that's not right either, so it's choice 3. Number 8, which type of bonding is present in a sample of an element that is malleable? So, malleable is a keyword for metal. Which type of bonding is present with metals? So covalent is metal, as 2 nonmetals. Nope. Ionic includes metal and nonmetal. So that might potentially be it. Choice 3 is nonpolar covalent. That's again nonmetals together, but metallic. That's a better choice. Metallic is all metal. Number 9. Which type of bond is found between atoms of solid cobalt? So cobalt here is a metal. And it's not made with any other element. It's not bonded with any other elements, just by itself. So we could cross off covalent. It's not bonded with a nonmetal, so we could cross out ionic. It's just metallic. All right, number 10. Which pair of atoms has the most polar bond? So we're thinking about bond. The polarity of bond is determined by electronegativity difference. Okay? So we're looking at each of these choices and figuring out which has the highest electronegativity difference. Okay? Because the bigger the difference, the more polar it is, whereas the less difference, the smaller that is, closer to 0, it's more nonpolar. So if you look at your handy-dandy reference table, look at table S and do all the math here. So I'm just going to list some of these electronegativities for some of these elements. H I know is 2.2, Br is 3.0, chlorine is 3.2, iodine is 2.7. All right, so let's look at each of these choices. H and Br have a difference of 0.8. I and Br have a difference of 0.3. I and Cl have a difference of 0.5. And H and Cl have a difference of 1.0. So the biggest difference is our answer, and that's HCl. Okay? So following that, we have question 11 where it's asked the electronegativity difference. So delta En, the difference between electronegativities between the atoms in a molecule of HCl can be used to determine what? So this is always used to determine bond polarity. Okay, so that is choice 3. Which phrase describes a molecule of CH4 in terms of molecular polarity and distribution of charge? Okay, so molecular polarity, on the other hand, is determined by SNAP. Okay, so symmetrical leads to nonpolar, asymmetrical is polar. So nonpolar, let's look at each of our choices. Choice 1 is incorrect. Choice 2 is correct. Choice 3, actually we're not even looking at the correctness of these statements. We're looking at CH4. So, right here. Well, it's symmetrical anyway, so I was right to circle that. I just wasn't reading. I just got lucky. Okay, So again, ladies and gentlemen, make sure you read carefully because don't jump to conclusions like what I just did. Okay? Number 13. Which formula is an empirical formula? So empirical formula meaning simplified ratio. So if you look at those numbers and see if you can simplify them further. So choice 1, C2H6, you can divide that further. That's a molecular formula, not empirical, because you could reduce that. Choice 3, you could also reduce. Choice 2, you can't, so that could be it. And choice 4, you could also reduce, so that leaves choice 2, because look at those subscripts. You can't reduce them any further. Number 14. What is the total number of atoms represented by the formula Al C2H3O2 3? Okay. Oh my god, that's a lot. So let's see over here. So Al, there's 1. How many C's we have there? We have 6, because there's 2 next to the C, and then 3 on the outside. You distribute it out. That's 6. H, we have 9. O, we have 6. Add them all together, and you get 22. That's a lot. All right, number 15. Which list includes 3 types of chemical formulas for compounds? So what are the 3 types we talked about in class, guys? So there's empirical, there's structural, and molecular. And hey, that's choice 1. Okay? We didn't talk about isotopic. That's not even a real formula. Covalent formula, no, and neither is metallic. Those are types of bonds, covalent and metallic. Okay, 16. Given the formulas of 4 compounds, which of these have the same molecular formula? Okay, so that means you're going to write out each of these formulas for each of these structures. So let's look at choice A. Structure A. There's 2 C's. There's 1, 2, 3, 4, 5, 6. 6 H's and 1 O. Okay, look at C. We have 2 C's. 1, 2, 3, 4, 5, 6. 6 H's and 1 O. Could be just A and C, but let's look at the others to verify. We got 1 C, 4 H's, and 1 O. The last one has 3 C's, 2, 3, 4, 5, 6, 7, 8, 8 H's, and 1 O. So it's just A and C, choice 1. All right, 17. Which formula is both a molecular and an empirical formula? So you're looking for something that can't be reduced any further, because molecular is the bigger numbers, empirical is a reduced. So let's look for something that is already reduced. Choice 1 can't be it. Choice 3, nope. Choice 4, nope. So it's just choice 2. All right, 18. Following the same line of thought. Formula A is CH3. This is an empirical formula because you can't reduce it any further. And formula B, C2H6, you can reduce that. So if it's not empirical, it's molecular. So going off that, choice 1 is correct. Now, which compound has the strongest hydrogen bonding? So hydrogen likes to have fun, you promiscuous little element. So it's the only one that fits the bill is choice 1. All right, number 20, we have boiling points for these 4 compounds. But look at there, H2O has a ridiculously high boiling point. So why is it unusually high? Look what there, we have hydrogen and we have oxygen. Hydrogen likes to have fun. So there's the O there. So it has hydrogen bonding. And hydrogen bonding is a really strong intermolecular force. And because it's really strong, you're going to require more energy to really overcome those bonds and melt it or even boil it even further. So that's why water has a really high boiling point because of hydrogen bonding. Okay, number 21. Which of these has the strongest intermolecular forces? And that would be HF. Why is it HF and not the others? Well, you need to look at their boiling points here. The higher that boiling point is, or any melting point, the higher that is. the greater the intermolecular forces are. So you need to look at those for boiling points and compare. All right, next. Which statement explains why Br2 is a liquid at STP and I2 is a solid at STP? So let's say, why is Br2 a liquid while I2 is a solid at the same temperature? So that means which one melted already? That means this guy already melted. Okay? This one melted already. That means this one has a lower boiling point, a lower melting point. Now, because this one has a lower melting point, it also has weaker IMFs, weaker intermolecular forces. Now, because of that, if bromine has lower melting point and weaker intermolecular forces, that means I2 has stronger forces. So it has nothing to do with really the polarity. It has more to do with the intermolecular forces. And so molecules of I2 have stronger IMFs than Br2. That's why. All right, which element forms a compound with chlorine with the general formula MCl? So we're looking for what M is. It's a metal for sure. Now looking here, each of these have imaginary subscripts of 1. So you need to go back and crisscross here. We know this is a -1, and so this one's got to be a +1. So we need to figure out which of these elements, which of these metals has a oxidation state of +1, and that is rubidium. That's our answer, ladies and gentlemen. Number 24, in which compound is the ratio of metal ions to nonmetal ions 1 to 2? Metal to nonmetal. So that means right here, the metal is 1 and the nonmetal here is 2. That means here, when we crisscross these back, this nonmetal has a -1 and this metal here has a +2. So all of these have calcium, which is +2. Now we're looking for which of these nonmetals have -1. It's not oxygen, it's not sulfur, they each have -2. Bromine does, while phosphorus here has a -3. Okay, that's why it's calcium bromide. Those are tricky ones. Number 25, a metal forms an oxide compound with the general formula M2O. In which group on the periodic table could metal M be found? Okay. All right, so here we have imaginary subscripts, crisscross them back. +1, -2. Oxygen, of course, is -2, so +1. So those are all in group 1. They all have +1 charges. An unknown element X can form a compound with the formula XBr3. In which group on the periodic table would element X be found? Just crisscross them back again. So +3 can be found in group 13. They all have +3s. Well, most of them do. Number 27, a solid substance is an excellent conductor of electricity. The chemical bonds in the substance are most likely, so a solid that is an excellent conductor of electricity. Okay? So it can't be ionic. They're only good in aqueous or liquid form. Liquid/aqueous, only in those two forms. Metallic, yes, it's metallic, but why? Is it because the valence electrons are stationary or because they're mobile? So think about when you dump NaCl, an ionic compound, in water and you dissolve it. Now, because these ions are separated, they're flowing, they're free, so they're mobile, not stationary. Because moving charges leads to electricity, guys. That you'll need to know for physics in the future. Number 28. Which statement correctly describes diamond and graphite, which are different forms of solid carbon? So they are the same element, but they definitely have different properties. And this relates to their different structures. So yes, they're the same element, carbon, but because they are different structures, they have different properties. So it's choice 2. Everything's different here. So this solid carbon is an example of a network solid, okay? It's hard, it's solid. Because of these different ways of constructing things, they lead to different properties. And finally, our last 2 questions. I'll put them in purple because that's one of my favorite colors. Number 29, which statement explains why an NH3 molecule is polar? So a molecule being polar, that means we need to look at SNAP. We look at the big picture. It's asymmetrical. Okay? If you even draw it out, it's asymmetrical. That's why it's polar. Choice 3. All right, next and last but not least, we have number 30. Fast one, last one, guys. We got to do this really fast. Okay, given the formula representing a molecule, we have a triple bond in the middle. The molecule is symmetrical, and when it's symmetrical based on SNAP, it's nonpolar. Excellent. And we're done. Yay, we're finally done. There was a lot of questions, but you guys made it through to the end. Excellent job, guys. Take care. Mapoy out.